Hey there, welcome back to Perry University. Today for our logics class, we're going to just do a real short, simple video about binary addition. Not too much of this one, so let's just start out with some basic terms that we need to be familiar with. All right, let's go over the most significant bit and the least significant bit. Not too complicated here, but let's say I have a binary number. Let's say we have 1, 0, 1, 0, which of course in decimal would be 1, 2, 4, 8. That'd be 10. So let's find the most significant bit. In this case, it's going to be the bit all the way on the left. That bit right there, that's your MSB, lowercase, and your least significant bit is the bit all the way on the right. LSB, least significant bit. So the most significant bit is the one with the highest power. So in this case, because this is column 0, this is column 1, this is column 2, this is column 3, this is 2 cubed. So 2 cubed is the largest value, it's the most powerful value. So that's going to be your MSB. Kind of like when you're working with regular numbers, say you have a number like 123 or something like that. This is your ones column, tens column, 100 column. Same concept. This would be kind of like your MSB, and this would be like your LSB. Just be mindful if you see MSB uppercase or LSB, that's most significant byte versus least significant bytes. Now we're talking about multiple bytes, which of course is 8 bits in 1 byte. So we're talking about a whole sequence of numbers there, not just the small snippets. Okay, so there's two important things that we need to keep in mind when we're doing binary addition. First is that it works basically the exact same as normal addition. Let's just to see what I'm talking about, for the heck of it, we're going to do 19 plus 35. I know everybody can do this, not to mention calculators is pretty easy, but let's just walk through it. So you start one column at a time, go right to left. 5 plus 9, 14, carry the 1 from the tens place, the 4 from the ones place goes down, 3 plus 1 is 4, then you got your leftover 1 up there, 5, it's 54, done. Addition we're going to be doing is no different than what you already know how to do. The other thing that's really important is overflow. So what is overflow? Overflow happens when the result has too many digits. For example, 4-bit binary has values 0 through 15, right? So 4 bits go 0 to 15, which is 0, 0, 0, 0 to 1, 1, 1, 1. And 4-bit addition overflows if the sum of any two numbers that you're trying to sum together has a value greater than or equal to 16 here, because 16 does not fit in that 0 to 15 window. And this is because another bit is going to be needed. You're going to have a fifth bit added on, and the fifth bit will get discarded, leading to an incorrect result. So let's take this bit of a mess away and kind of see an example. So to demonstrate what I'm talking about, let's add the numbers 13 plus 5. I think we can all pretty instantly see we know the result. 18, obviously, right? If you don't know that's 18 off the top of your head, probably need to go find some different tutorials. So let's put this into binary. So what's 13 in binary? That's going to be 1, 1, 0, 1. Kind of double check. We have 1, 2, 4, and 8. 4 and 8 is 12, plus the 1, that's 13. 5 in binary, that's going to be a 4 and a 1. So 8 is going to be off. We have 4, no 2, and we have a 1. So 0, 1, 0, 1. And now let's sum them. So let's walk through this step by step as well. So what's 1 plus 1? This is where it's weird. 1 plus 1 here, even though we're in binary, we're still going to say it's 2. But remember, the 2 equals in binary 1, 0. That's not 10, that's 1, 0. So we have a 1 that's going to get carried, and we're going to put our 0 down here. Next column, pretty straightforward. 0 plus 1 is just 1. 1 plus 1 is 2, which is 1, 0. So you carry your 1, put down your 0. Now we have 0 plus 1 is 2 again. So 1, 0. So we have 1 and 0. And let's draw a line here. So here's our 4 bits, but we have this extra 1 over here in a column that doesn't exist. And the issue is, even though this would come down to 0 plus 0 plus 1 is just 1, this is an overflow because everything to the left of this line is going to get discarded by the computer. So even though the answer would be 1, 0, 0, 1, 0, which let's just make sure that's 18, that's 1, 2, 4, 8, 16. So that's 16 plus 2 is 18. Yep, that's 18. What the computer is going to see is 0, 0, 1, 0, which equals 2. So that's the result that the computer is going to store in memory, which obviously is completely incorrect. So that's why overflow is important, and that's why you need to be aware of it. Okay, so for the time being, let's just go ahead and do some examples, and let's say that we're doing 1 byte. We're going to add 2 numbers, 1 byte each, together. So remember, 1 byte is going to be 8 bits. And let's, just because why not, let's do 13 plus 60, which is pretty easy to see. That's just 73. Okay, now let's do that in binary and see what we get. So 13 is 1101, but remember we have a whole byte, so make it 8 bits. Okay, and 60 is going to be 111100. But again, we have to make it 8 bits. There we go. All right, let's add this up. 0 plus 1, 1. 0 plus 0, 0. 1 plus 1, 2. 1, 0. 1 plus 1 plus 1 is 3. Remember, 2 binary, 1, 0. 3 binary, 1, 1. Okay, so carry the 1, place the 1. 1 plus 0 plus 1, that's 2. There we go, we have 2 again. And then this is 1, and then 0 plus 0 is 0. Now let's add this up to make sure that we have what we want. That's going to be, that's 1, 2, 4, 8, 16, 32, 64. 64 plus 8 is 72. 72 plus 1 is 73. Yep, 73. Let's do one more. We're going to make it 4-bit. So let's add 1 and 7. So 1, 4-bit, pretty straightforward. 7, there we go. All right, we know we're adding 1 and 7, so we should get 8. 1 plus 1 is 2. 1, 0, 1, 0, 1. That's going to be 2 again. There we go. We have another 2 and a 1. There we go. 1, 0, 0, 0 does equal 8. I'll make this formal. And there you go. Those are just some quick examples. Wanted everybody to kind of see what's going on there because this is going to become very important for the next video, which is a bit more involved. And that's going to be 2's complement, where we're doing signed and unsigned binary. Thank you for stopping by. I hope you got something out of this. Have a great day.